of this discussion, as this is something which is very close to what I do day in, day out. Uh, from my experience, I believe like most of the teams don't really have a data problem. They have like a correlation problem. We are drowning with logs, metrics, traces. There are lots of signals, but a lot of times they are not stitched together in a way that it tells a coherent story during an incident. So it feels like, a ground for a new detective operation every time when it happens. So,
Mhm.
yeah, looking forward to hearing thoughts from all of you.
Sounds good. Ishan?
Hey guys, I am Ishan. I'm a software engineer to application DevOps at Mastercard. I'm an AWS community builder, a Docker captain, and recently I started maintaining a project called Valky. I maintain Valky Helm. I do like a lot of coffee, so if you guys have anything related to coffee, do ping me. Apart from solving incidents at midnight, I also have a very peculiar hobby that I look at log pipelines at 2 a.m. and think why I'm doing this right now.
Sounds good. Sounds good. Musharraf, would you mind unmuting and give us a quick introduction?
Yeah, thank you, Manas. Okay, hi everyone. My name is Mosharaf. I'm based out of Hyderabad. I'm currently working with OpenObserv as a solution architect. Basically, I'm a here observability expert. Just because I was a Splunk engineer and as well as a consultant, core consultant, where I helped organization build and optimize their monitoring and data pipeline, data analytics pipeline. So today, I focus on helping teams gain deeper real-time visibility into their systems. So yeah, that's me. Thank you.
Thank you. Thank you, everyone. First of all, I'm pretty excited to host this amazing panel. I had a poll running in the meanwhile, and I can see like most of the people they said during an incident, where does most of your time actually go? There were a few options, but the most selected option is correlating logs, metrics, and traces. And I think that's exactly why we are here. We are here to talk about our stories, what happens and what not. So I want to start with the first segment where we're going to talk about some war stories. So I have a question for you, Ishan. If you can tell us about an incident where Kubernetes, okay, Kubernetes looked perfectly healthy, the infrastructure, but something underneath was quietly broken.
Yeah,
Mind to share?
so it happened like a month or 2 months ago. So it was here around 10:30 India, 10:30 a.m. IST, and everyone was just starting. I got a ping from one of the developers saying his test pipeline is failing, and the new application is not being deployed. I said, okay, I'm going to take a look later. Uh, then I was making coffee. That's why told it that I'm going to take a look at it later. Then he pinged me again, Ishan, please, it is failing. I need to do an NFT and I need to submit results. Okay. Then I asked him, send me the PR, send me the pipeline link. Let me check. I checked the PR, nothing was fishy. I checked the pipeline was passing. That means something in the cluster was not. I logged into the cluster and then I checked what is happening there. So I saw there is an image full back off
Okay,
error happening.
okay. Image pull back off, right? So
Yes.
and so where do you even look next?
So first of all, I thought the image is not there because because the pipeline was designed in a way it was not a complete CI/CD. CI was different and CD was different. So he did not run the CI pipeline. And I checked the CI pipeline. It
Mhm.
ran. I checked the image registry. Image was there with the tag he had deployed. And then cross-verified with the PR and inside the Kubernetes cluster by describing the deployment. Everything was right. Okay. Secret, it's there. Then I thought that I asked, what did you check, the developer? Because that cluster is not my responsibility. I was just asked to help around. Okay. He said, I checked logs. And I said, wait a second, why did he check logs? Because if it is image full backup, that means a container never started. If the container never started, there are no logs. Then I described the deployment and checked the events. And it was a Nexus, uh, it was a registry timeout saying registry, we cannot access it. By the time it was 11 India time, but I am SRE based in India, but my team, all of my team is in UK. So nobody was there up. So I just pinged the all call guy up saying something is fishy, let's debug it out. And what we got to know is as we run on-prem clusters, we somebody when these cluster and data centers were getting up, they hard coded the IP of uh, our repository into each and every cluster. We had 15 clusters. We have 15 clusters, meaning every one of the cluster was connecting to a single repository. If something is changed, let's say our cache clearing cron jobs are running and they're removing all the images to free up the node space, uh, any new container restart, it would go into image pull back off and it would cascade into a PG.
Okay, okay. Hey, I want to just pause you right there. I want to ask one question because I'm very curious. How much of all this was technical versus just knowing how your organization works, who to ping, who changed what overnight?
Yeah, so uh, the thing is that first let me tell you why the IP changed because the registry was moved from a standalone VM to a Kubernetes cluster. So they changed it. So that's why the IP changed.
Hmm.
Otherwise, nobody in the last 5 years looked at it saying this is going to happen. Now, understanding that this change happened, so I went to the organizational chat where this thing happened and they said we have migrated our registry from this to this last night. All of this was organizational context. It was not a technical issue. Understanding what is happening, okay, the developer did not have the context of how to debug Kubernetes, saying what is happening because everything was right. And
Hmm.
we never make dashboards for these kind of issues. We make dashboards for CPU memory latencies, everything in that realm, not here. And
Correct.
the problem was I could not have debugged, I could not have fixed this issue. There was a separate team who manages the platform. We
Hmm.
run applications on that platform. We are
Hmm.
application DevOps. There is a platform DevOps, there's a separate team. So everything was a organizational context. I woke my on-call engineer up. We got in, we raised tickets, and this cascaded into a internal major incident, saying this should not have happened, how this happened, and it was silently failing for the last 5 years. It was not failing because something uh, changed drastically. It's just that the IP changed. And
Hmm.
why the D and when we did the RCA we had why it was not the DNS but the IPs directly.
Got it. So again, I understand like these kind of silent failures happens a lot of times more than we anticipate them.
Yes.
Someone change someone, some team, some guy, they change something and it's gonna impact multiple services. This is how microservice architecture is today. Okay, this is my understanding. Services are dependent on each other. I just want to quickly ask Radhika or Musarraf if any one of you have hit one of these silent, looks healthy failures.
Yeah, definitely. I think there has been like these sorts of organization silos and something's going in production. I think such big change there should be definitely checked with like a playbook should be there. Like what are the effects of changing this IP? I think engineering best practices are never should not be treated like a substitute for observability. And like for example, instead of IP, there should be like a DNS. So even if whatever underlying IP is changing, then it doesn't break the system. So
Hmm.
definitely, yeah. But I've seen like organization silos and a lot of knowledge being tribal knowledge and not really propagated. So yeah, that
Yeah.
happens.
No, yeah, I think that makes a lot of sense. So again, since you're already speaking, I would like us, like you particularly, to tell all of about like all of us, our audience, if there was a time when you got alert, okay, someone paged you, and the root cause was in totally different parts of the system. You talked about silos. So how did it unfold? How was it for you? If you can just tell us a little bit about that experience.
Surely, yeah. I have an interesting story around this, which recently happened. Like, So I got paged with like a SLO alert, P99 latency of a critical API suddenly has spiked up and it has started burning the error budget. So of course, my first instinct was like something has gone wrong with the application, and I'd started looking around the service. So I checked the pods; they were running fine. I looked at the resources, memory, CPU average; they looked normal. I checked the application logs; there were no like obvious errors there as well. So everything in the immediate blast radius like look fine.
Mm.
So I did what we all naturally do. I treated it as a like a application problem. I opened the service Grafana dashboard, checked the database query, dug into like the cache behavior, looked at like downstream dependencies, and spent like solid 20 minutes to chasing around like signals around the single service if I can see what is going wrong, but nothing was lined up and the service was showing healthy, but it was still like the alert was still there. So users were experiencing latency. So it was like one of those situation where you start doubting the alert itself, like, oh no, what's happening? I'm not able to like really understand.
Yeah.
So I was then thought, okay, let's pause. Let me take a step back, look at the cluster and see bigger picture of like what's happening there. So I started looking at cluster, I started looking at node, and then I looked at this particular node where this service was scheduled. So when I was looking at node, I realized the node CPU was quite high. It was almost saturated. So I went ahead to see like what's scheduled on the node, right? What's causing this high CPU? And that's
Mm.
where I saw like there was another batch workload which has got scheduled on this node. So that's when something struck me like, okay, this might be something which could lead me to the right symptoms. So I then looked at like when I looked at this batch workload, it was consuming like bulk of the CPU on that node. Then I looked at the CPU throttling metrics and I could see that the API workload was actually throttling. So
Mm.
what was happening was the batch workload, which got scheduled on the same node where the API pods were running, uh, it was consuming a bulk of CPU, and that's why the API pods could not get like enough CPU quota on the
Mm.
time within that window, and every API request was like quietly queuing up for CPU, which it could not get fast enough. So from Kubernetes point of view, like everything was in running state and no pod failures, no application errors, no restart, but those pods were effectively starved. The API pods were effectively deprived from CPU. And that's why like this latency error was there. Of course, the fix was pretty straightforward once I realized that I scheduled the batch workload on a dedicated node pool so that gradually the uh, CPU from the API pod for the API pod was now available, and then the latency dropped. And then, of course, like the alert was cleared, and like the
Mm.
service was working fine from the customer perspective. So, yeah, I think sometimes it's like you look at the one thing, understand, like you are sometimes so much into that if this is application, this is a alert related to application, it might be regarding that, but then it is something completely different than what you think
And I
of.
think like that is how humans normally process information. Okay, this is
Yeah.
what human instinct looks like. I have just one follow-up question for you, Radhika. So looking back at all of this, if if you were in that same situation now today, what do you think, what would be that one thing which will help you get faster to the root cause? Or you can just do all of this same thing what you did but just faster. What could that be one thing?
Yeah, definitely. So this is not like a usual thing. Sometimes that is a unusual cause or a usual problem. So I was treating the service boundary as a system boundary, which I should not be doing. So I definitely, if the alert would have like a richer context, like if it would have a snapshot of the node CPU details and CPU throttling metrics, that would have like definitely helped me. I would add that to the alert. I would add that line to the runbook that if the latency is high, the application metrics look normal, everything around the application is fine. Check the node level throttling, check the node CPU and the CPU throttling metrics for the containers. So next time whoever is dealing with this sort of alert, he's ahead of, or that person is ahead, they are ahead of
Yeah.
just looking into the application metrics and start thinking in that direction if the uh, prior metrics look good. So yeah, I would do that.
Sounds sensible. Ishan, if you get a P99 alert, okay, what is your instinct? What are you gonna do?
Okay, P99 alert, it must have a service and an environment. I would go to the dashboard and open up the traces, seeing what is happening. Because P99 is spike in latency, correct? So latency, as we work at distributed systems, we have a producer, a consumer, a queue in between, a database, session storage, a cache, and everything. Anything could be a failure. Traces and spans help us which component is taking how much amount of time. But in this case, it would have been okay because the issue was on the infrastructure side, not on the connection between these infrastructures and a request traceability. So this is what uh, I would have done because of my habit of looking at alerts.
Hmm. Okay, got it. I think that's the right instinct as well. Now I think thanks again for sharing these stories. Thanks Ishan, thanks Radhika. Now I would like to move on to the next section of this discussion, which is common challenges. Okay, and if I this is a round robin section, so all the questions which I ask they will be directed to all three of you. So feel free to like go one by one or whatever. If you have some thoughts, just let us know. We can take that forward. So my first question is, what is the biggest reason Kubernetes teams still struggle to get from alert to root cause quickly?
Not
Let me give you an order. Yeah. Ishan, you can go first
yeah,
since you're up. Yeah.
not naming the alerts correctly. So
Okay. Good.
and this is the first and the major thing that what I have seen here is
Mm-hmm.
second, not writing correct runbooks. So let's say if an alert comes in, what is going to happen and
Mm-hmm.
what you can do.
Mm-hmm.
After that, not patching up those alerts. Alert means a chink in the armor, you need to patch it up. So
Mm-hmm.
what Kubernetes teams are doing is they have so many alerts, they get alert fatigue and then they turn a blind eye into alerts because everything would self-heal in some amount of time. So I think it's ownership and how to understand observability as a whole. So ownership and understanding of the system, these two things are the major things why Kubernetes teams are still struggling with alert fatigue. Because I have started like 4 years ago, and in 4 years, the one constant thing that I've understood is and I've heard is alert fatigues, and nobody's trying to patch them. It's because of the ownership and the skills.
We open observer is trying to catch them, and at the
Yeah.
end of this session, we'll definitely show you how we do that. So again, Radhika, same question. Biggest reason Kubernetes teams still struggle to get from alert to root cause.
Yeah, for me, I think from my experience, I see the biggest reason could be like sometimes the context fragmentation. So,
Mm-hmm.
and by that I mean in terms of tools, in terms of teams, in terms of dashboard. So the signal that tells you that something is wrong and the signal that explains why it is wrong is usually living in like different tools, different dashboards, and often different teams.
Mm-hmm.
So it's like difficult to gather the whole context together. You normally get like you start with something like a pager duty or somewhere where you get pinged, then you jump on a visualization tool, Grafana, Datadog, then you go to like kubectl, run your commands, you check in like GitHub what has been deployed or what is the recent code change, then you go to Slack to find some past context, and so you're basically like reconstructing the whole system in your head under time pressure. So logs, metrics, traces, I believe like all are there, but they are not aligned to answer the question you want to be answered during an incident. So yeah, I feel like if there is like a one unified way of connecting it all together, that would be like great to understand like what's happening, what caused it,
Mm-hmm.
uh, and get the whole picture together.
Yeah, lot lot of it does sounds like resonates with not just open observe or what I see. So when I talk to customers and I talk to users, this is not just like problem at your organization or Ishan your organization. This is a problem like across the globe, different type of organizations, different industries, different sectors. But yeah, let's talk more about this very shortly. Musarraf, if you have any thoughts, sir, please tell
Yeah,
us.
yeah. For me, also it's same as the Shan. It's the alert context. Okay, so basically, alert tell you something is wrong. Okay, but when it comes to Kubernetes, right, it scatters like it's a big question mark. Where, right?
Yeah.
So let's suppose like the alert fires on some like alerts always fires on some symptoms. Okay, so let's suppose okay, there's a crash loop back off. Okay, but that's not the actual cause. Cause is something else. Okay, to figure out that something else is what is still a like mystery. Okay, so yeah, like yeah, we'll cover this part as well later. But yeah, so this alert context is very important. Yeah.
Hmm, got it. Okay. I think like again, listening to all of you answering this and hearing war stories from Ishan and Radhika, what I understand. So again, just reiterating or recapping for our audience, the war story which Ishan told us that there was a registry change and that led to a lot of things going down. In case of Radhika, there was a batch workload which was running on a like the resources were not appropriate and the batch workloads were running ended up throttling the CPU. And I think it's safe to say that it was just sitting in a different signal. Okay, the logs which Ishan was trying to look, he's trying to find the place where he was trying to find the answer. It was just not there. It was someplace else. It was some other logs. Probably if we had some event logs, then it would have been very much easier to get there. So this is what I want to talk about: the gap between application and infrastructure. And this is where the time goes. So Kubernetes is just the infrastructure. Applications which are running on top of that, they go down. This is what the end user is getting impacted. All of us in every organization, we are running behind SLOs and SLIs. Just because they impact our end users, we cannot afford downtime in 2026. I think that's unsaid thing. Now I want to just talk about one idea, which is temporal correlation. So you get traces, you get metrics, you get logs, you have the cluster state in that same time window. So what does temporal correlation means? It means you start like what we were trying to correlate, right? What was happening in my logs and traces at that period of time. You start looking at logs first, then you look at traces first. Now there is another concept which is I think which it resonates to the temporal correlation concept, which is called dimensional correlation. What dimensional correlation means, that you link these different signals, Kubernetes signals, by a shared tag. What it means, a namespace, a cluster, a service. So, for example, just using your example, Ishan, if that registry IP change had been logged and tagged by a service, okay, there was be just a simple tag called service underscore name or service dot name. A correlation engine could have flagged it as related a day before anything broke. That someone who changed this registry in this specific service, and this would have been, I think, highlighted or surfaced very clearly. And this is the one place where I want to mention that what we build at OpenObserve, we lean on exactly that. We lean on temporal correlation as well as dimensional correlation. No, this is not the time where we screen share something. Let's talk about some best practices first, and then we'll maybe show you a couple of things which how we do that and how you guys can also implement that in your setups. Okay, so let's talk about best practices. So again, all of them should be, since the name suggests, it's practical information, which our audience, I would request our speakers to make sure whatever best practices or recommendations you share with us today, keep them so that keep them like very basic or 0 to 1, so that even they can go ahead and implement them in their ecosystem or in their setups. My first practice I want to understand is, in any incident, okay, we just talked about, there are things which constantly takes a lot of time, and it consistently cuts the mean time, like it extends the mean time to resolution during an incident, during a Kubernetes incident. So the one thing which we know is ownership. It is very important in organizations like Mastercard, Writer, and any small to medium, big enterprise. Okay, the ownership is very important. Which team is responsible to resolve this incident? If it's application team, is it a third party vendor or whatnot? So how do you get the right owner, and like how can you get it fast? That's my question.
So, uh, I have a best practice about it. See, don't wait for the system to fail. As we say in distributed systems, systems are meant to fail. There is 100% guarantee that a system, given enough amount of time, would fail. So, what I started to do and what I learned in my journey is do war games. What is a war game? War game is you deliberately fail a system, check what is happening in the system, how system reacts. Is it self-healing? Okay, what alerts are going to come in? You have lower environments for this only. Have an environment that is as closely related to production as possible. Fail that environment, understand how the alert flow works in who is going to get a call. Okay, it is your team or somebody else's team. How to do it, and you make practical run books, not theory run books. What most team does is, okay, we have this, okay, this 5x6 error is there. Okay, this is the run book. They never test it out if that run books work or not.
Hmm.
Better option is do war games around things. What we do is every 2 weeks we block 1 hour, uh, tell the team like we are going to do this, and we do it. We fail system deliberately. Somewhat chaos engineering. Uh, Chaos Monkey is the tool that Netflix made and open source around. But yes, this kind of chaos engineering would help you understand how large scale distributed systems fail. Because when they're running, it's a smooth train, but when they fail, it's a big bang.
Yeah,
So better to minimize your blast radius.
makes sense.
Yep. I think I would definitely add to what Ishan is saying. Definitely chaos engineering with a good perf testing that can help to predict how a service would behave under load or in the real world production environment. I think along with that, when we are creating the alerts, making sure that it has good context with labels like what is the service. It should have basically first a good description, like, what is that alert about and what it signifies. It should have those minimalistic labels around what is the service, what's the component, what's the namespace, what the team it belongs to. And it should have like a run book, not with like a generic run book, but a detailed run book with, of course, like because every system has some organization context as well. So some organization context around that. And as per that, like what are this step 1, 2, 3, 4 would you do so that anybody is able to like follow that. Uh, and of course, like a good escalation path. If, okay, I am still not able to solve this following the run book, like what I need to do, I probably need to reach out to the expert for that. uh, I think that would be great. Also, I think I see a lot of alert fatigue. So normally teams start with like a threshold based alerts. I think once it's evolved, it should be to the SLO based alert. So the teams are alerted based on what's causing a user impact.
Mhm.
And then, of course, there can be a mix of these SLO based alert plus something like infrastructure related alerts, like not for like one pod going down, but maybe for like all the pods are crash looping, something like that. But yeah, so I think a mix of both of that to avoid like a lot of alert fatigue, plus as well like good alert structuring with necessary labels, run books, that can like definitely help. And of course, I think in today's era, using AI for understanding like what's happening across different signals.
Yeah.
that can really help quickly, because as a human, it's very difficult to comprehend all these different signals, especially with Kubernetes, what's happening at networking, storage, infra, application, and
Mm.
DNS, all the different layers and the ecosystem which it brings it with itself.
Yeah. I think, yeah, I think like the manual correlation, which, so this is the era of AI. Okay, all of us are depending upon AI to automate our redundant jobs. And being an SRE, you guys are SRE. So this is what I believe, that SREs are like the first line of defense. Anything goes down, SRE is the one everyone tags, whether it's your team's chat or what is happening, what not is happening, right? And it's very important to understand that SREs are not no god, right? They also need to spend some time, dig into logs, metrics, and traces, and then come with the assumption that I think this is happening. Now, if you put AI to work to do all of this manual work, correlating between different signals, trying to group related alerts together, then it's definitely gives a good head start. This is what I believe. But Musarraf, or like again, this is not a question respect to Musarraf, but I would love your thoughts on this. That what is one observability practice that you believe teams pour a time into, but it does not pay off well?
Team invests too much time in learning the process or product instead of get knowing the uh, like how actually it works. So these two are two different things actually. Learning the process and how it works is two different things. If you know how it works, you know how you can use it or how you can fix it, how you can update it, everything. So that makes a difference.
Hmm. True. Radhika, same question.
Yeah, I think I feel sometimes we don't ask the very basic questions of like what I should be monitoring, what are those signals, instead of like collecting everything and creating dashboards for everything. Like what are the primary things which I should be knowing, and what would give me the most gain. For example, something like uptime or probe checking can help in monitoring the all the expose URL, internal, external endpoints, the third party URLs. So we know for sure that it's working or not. So understanding what we want to monitor, why we want to monitor, what's the impact of, some critical service going down, what is that? So I think this definitely involves like a stakeholder discussion with all the product engineering, sometimes customer teams. So, and building observability around these parameters, I think, is very important, rather than just having the metrics out there, uh, is what I feel.
Yeah, sounds good. Ishan, you mind sharing if you have any thoughts regarding to like
Yes.
what is the like where teams pour into time? And just
Yeah.
I want to give an add-on question to that directly to you, since you are like running very time, like we are running short on
Yeah.
time. So if there is like, what did you actually change? So I understand the
Yeah.
problems now. It's manual correlation. It's not a very mature RCA practice within the organization. If you can also share along with any
Yeah.
like immature
Yeah.
practice which you see, but how you are changing that.
Sure. So one thing that I have seen is dev teams, they write logs, they write metrics, they do very beautiful stuff. SRE teams, they build very beautiful dashboards, but there is no correlation between them. Saying what they have done and what we have made is not there. What I have changed in the process is deliberately sit with the developers saying, okay, why this is happening? What are the failure modes that you have tested? Okay, is your application doing these best practices?
Hmm.
Because of this, get so DevOps means developer operations, correct? SRE is site reliability engineering. I have mixed everything together, saying I am going to sit with developers to understand what they are doing and then create dashboards and alerts on top of that. So that when my SRE team, when my all-call engineers are there, they don't feel like it's 1,000 alerts are blowing in and I cannot do anything. So this is what I've changed. This is how I educate my team saying observability is not an afterthought, it's a first class citizen. Make your
Mm.
application in a way, if it fails gracefully, and we understand why it fails. Most times when we are wasting time in incidents, there is no documentation how it fails. So understand failure modes. That's why doing war games, doing all of these activities, educating your team is also very important.
Yeah.
It's not just firefighting, it's education as well while doing that.
I see. Sorry to talk in between. I see Musarraf nodding. So maybe Musarraf, if you can show us how it looks, what we have built in OpenObserve, how we are doing this, that would be great.
Sure, sure. Okay, I will quickly share my screen. Before that, I will just add few points. Okay, so we all use alerts. We discussed in this session as well, right? Okay, we can trust alerts. We can't trust alerts. Why? Because the area is quite big, right? So basically, in the end, it's like if you consider it with Kubernetes, right, or with any environment, it's always kind of the bottleneck is always the correlation. Okay, it's not the detection. Detection is everywhere. After detection, what we can do? So that's where OpenObserve comes in. Okay, so let me share my screen. Okay. Mm, okay. Yeah. Okay. Just confirm if my screen is visible.
Yeah. Can
Okay.
you zoom in a little bit? Because I think this is a vertical screen, I believe.
Yeah.
So
Okay.
that would be good.
Is it fine now?
Yeah, this is good.
Okay. So all other tools, like we also have the alerts. What's new? The new is the SRE. Okay. Let's suppose I will just take an example from our session today. Okay. Uh, Ishan mentioned about that image pull errors, right? Okay. We have alerts for image pull. Okay. Once we have that alert, okay, the traditional way is okay, I'm getting alerted. I will go back and check here and there manually, try to figure out what happened, how happened, if anything changed, and all those stuff, right? Now here we have one option as create incidents within the OpenObserve. Okay. Now what this create incidents do? This create incident will first analyze your alert. So OpenObserve will first analyze your alert, will see whether the similar alert was generated earlier or not. If it got alerted, so there might be a incident already available, and it will simply tag it to the same incident. In that way, you won't be busted with multiple alerts. You have just one single incident, which will have the correlation between the multiple alerts. Okay. Now, once the incident is created, okay, this is the view which you will get in OpenObserve, okay, where it will show you the correlation between, okay, how many alerts are related with this one single incident. Okay, what are the, like right now I can see like there are three unique alerts which got triggered. These are the number of total alerts it got triggered. Okay, these are the estimated affected services. Okay, all those things it will first analyze how it is doing that. Okay, so we have this incident analysis within OpenObserve. Okay, now I have. I'm coming back to the Radhika's issue, right? Radhika said like there was a CPU spike, but we couldn't find it. It was because of some batch process. Okay. Now what this O2 AI SRE do? Okay. The moment this incident is getting created, it will do a RCA for you. Okay. In that RCA, it will analyze your logs, metrics, traces, everything, a single correlation, which was the bottleneck till now. Okay. Now, once the correlation is done, it will give you, okay, which all application or services are affected. Okay. It will provide you the like proper evidence. Okay. This is where the change was done, or this is what, because of which this alert got triggered, or this service got impacted. And in the end, it will give you it will give more details as well, like in-depth RCA. Okay. In the end, it will give you some. This is the recent change. Like if there is any recent change in the pipelines. Okay. And in the end, it will give you the action. what action to be performed. Okay, I will show you one more, a simple one. Okay, which everyone can understand at one shot. Okay, we have PVC bound, no pod attached,
Oh,
right? So my pod is not attached. My disk is there. I'm still paying for it. It's almost a month. I'm not aware about that. I created an alert. Okay, I will. What I will do? I will go back. Okay, I will try to figure out which all PVCs I have, which I need to remove, and I will take a note. What AI SRE is doing is doing your work, getting everything, giving you the list of PVC names which you don't want. Okay, you are new to Kubernetes. It's in its action. It's even giving you the commands as well. Okay, go and run this command. So that's how it will. The time to resolution. Okay, a time to fix will be very less. Yeah,
Love it, man. This looks
yeah.
super cool. I would love to get to the audience questions. So while you were sharing this,
Yeah.
we had some good questions. So for the sake of time, I would just limit our Q&A to just one question, and probably every one of you can chime in there, share your thoughts. But what is your favorite Kubernetes signal to watch? Let's go one by one. If Ishan, you wanna go?
events.
Okay,
They
Kubernetes.
tend because Kubernetes do a lot of telemetry on its own, but
Yes.
you need to look, you need to find where they are, and events is the place.
Mm. Just for everyone reference, like pod restart, pod got scheduled. All of these
Mm,
would come under events.
yes.
All right. Radhika?
That's an interesting one. So I think at different point of time, different signals, but I think traces could be great because you can correlate it with logs and metrics. So it's easier to build that correlation around.
Mm.
So, but yeah, definitely like depend on what is the issue at hand we are solving. Sometimes it's, with metrics or logs, we can get a good understanding. But I really believe like traces could be a good key to connect uh, all these telemetry signals together, and then it's easier to understand those complex issues.
Awesome. Awesome. Okay, I think we are at time, first of all. So I would love to just say thank you to Radhika, Ishan, and Musarraf for exactly the conversation I hoped for. Okay. I hope our audience also like this conversation and whatnot. And if you want to like keep going after this session ends, we're gonna share you the recording of this session along with a few links to get started with a trial and our guide to Kubernetes monitoring. So feel free to check that out. Apart from that, I just want to take a second and show one more thing, which is another similar panel discussion, which we are doing on August 18th. So it's happening on a little different time than this. It is more, this is Pacific time zone, Eastern time zone. So their morning, probably like India evening, and little somewhere between for people in Europe. This session is around AI. So if you are someone who is trying to build AI agents, who is trying to run LLMs in their organization, and they want to move that, right now a lot of teams what I keep talking to is that it's in lower environments, it's in staging, they have not yet pushed to production, and there are some real fears pushing an AI agent to production, because this is how it works, very simple. So we're going to talk about this, how you can get your AI agents ready. We talk about reliability. We're going to talk about cost monitoring and whatnot. So you can find this in openobserv.ai website under webinars. But yeah, that's it for today. Thanks again for joining us, and probably see you in the next session.
Yeah. Bye bye.
Awesome.
Thanks, Manas. Yeah.
Thank you. Bye.